Hi, I'm Cam Soper, a content developer here at Microsoft working on dotNET docs. Today, in this video, we're going to get started with Entity Framework Core, which is a tool set that makes it easy to store your dotNET objects in a variety of databases without writing much, if any, database code. The database we're going to build supports an online retailer, Contoso Pets, which markets dog toys. The customers table can have 0 or many orders associated with it, and each order has many products associated with it. This is enabled by way of an intersection table, which facilitates a many-to-many relationship. Let's get started with a demo. I've got an empty console project here, created with dotNET Core 3.0. I'm going to go manage my NuGet packages, and I'm searching for Microsoft.Entity Framework Core. I'm going to grab the Microsoft.Entity Framework Core.SQL Server package and install it to my project. Now that that's installed, I'm also going to install Microsoft.Entity Framework Core.Design and Microsoft.Entity Framework Core.Tools. To get started with Entity Framework Core, we need to build an entity model. By convention, this is usually stored in a folder called Models. We're going to create the first table, probably the simplest one, products. So we've added an empty class, and I'm going to use Visual Studio's snippet feature to save some typing. Looking at the product class as we've built it, the first thing that I want to call out is this first property, ID. In Entity Framework Core, ID is a special identifier that indicates that this property is to be treated as the primary key in the table that gets built. It doesn't have to just be ID. It can be table name followed by ID, or it can be anything we want it to be, and we mark the property with the key attribute to indicate that it's a primary key. The other two properties on this class are name, which we've marked as required using a data attribute, and also price, which we've indicated is a decimal with 2 decimal points of precision. The next class we're going to add will be the customer class. The customer class looks a little bit different because this time we're using the nullable reference type feature of C# to indicate which fields allow nulls and which ones don't. Since first name and last name are not nullable strings, Entity Framework knows that when it creates the table, those 2 columns should not allow nulls. The address and phone properties, on the other hand, are nullable strings, so Entity Framework will allow nulls in those columns. Finally, the last property on the class, called orders, is a collection of order objects. We haven't created the order class yet. We're going to do that in just a second. This is called a navigation property, and it indicates that a customer may have 0 or more orders. This creates a one-to-many relationship in the database that gets generated. Creating the empty orders class, I'll again use a snippet to populate my properties in the class. This shouldn't introduce any new concepts. We have our ID property, our order placed property, which is a date time, an order fulfilled property that gets populated when the order is actually fulfilled, and we've implemented that as a nullable date time, so the database will allow nulls in that column. We also have a customer object, which is another type of navigation property, 1 customer per order. We have a customer ID property, which represents the foreign key relationship to the customer table that will be generated. If we didn't include the customer ID property, it's okay. Entity Framework Core would create it anyway as a shadow property. Finally, we have another navigation property to point to our intersection table, product orders. The final class we're going to create is the intersection table. The intersection table, product order, facilitates the many-to-many relationship. It has navigation properties for both order and product. And just as with the other class, The order ID and product ID represent foreign key relationships and aren't strictly required. Now we're going to create a database context class. By convention, this typically goes in a folder called Data. I'm going to name my class Contoso Pets Context. Contoso Pets Context derives from DB context. Think of DB context as representing a session with the database. On the DB context derived class, we have 4 properties of type DB set. Each DB set represents the table that will be created in the database. Finally, we've overridden the onConfiguring method to include some configuration information. Since we're using the SQL Server package, we have a use SQL Server extension method available to us that indicates to Entity Framework that we're using SQL Server. We pass in the connection string. And by the way, you should probably never hard code your connection string. We're just doing this for demonstration purposes. So now that we've created our entity model, we're going to create something called a migration. Migrations are tools that make it easy to create and evolve our database. I'm going to use the Package Manager console to run the add migration commandlet. And I'm going to name my migration initial create. Let's take a look at the generated code. Unlike some generated code, this code is ours to maintain. We should look it over to make sure it's accurate and that it creates the table the way we want it to be created. Looking at, for example, at the products table, we can see where it's creating our identity column, our primary key, our name, which is not nullable, and our price, which is a decimal with 2 decimal points of precision. So now that we're satisfied that the migration is correct, we'll run the migration with the update database commandlet. All right, that's run. So let's take a look at the database that was created. The first table we're going to look at is this one that we didn't create at all, this EF migration history. This table is used by Entity Framework Core, so it knows which migrations have been run against this database. Let's look at the products table. It looks like the products table was generated exactly as we intended. And let's also look at customer. The customer table was also generated pretty much as we expected, except I realized that I forgot to add an email column. Let's go back to the customer entity and add a property for email. Email will be a nullable string. Now that we've modified the customer entity, we'll create another migration. I'll name this one add email. And if we look at this migration, we see that it's pretty simple. All it does is add a column. Let's go ahead and run update database again to make sure that our database is up to date with our migrations. As expected, the email column has been added to the table. So now that we've built our database context and our entity model, let's do something with it. To get started, I'm going to add a few products to my products table. The first thing I'm going to do is I'm going to use a using declaration to create a new instance of Contoso Pets context. This using declaration ensures that the Contoso Pets context object is disposed of properly when we're done using it. The first product I'm going to add to my table will be a squeaky bone. You'll note that I create the squeaky bone object and then add it to the products table on the DB context instance. The next product I'm going to add will be a 3-pack of tennis balls. Note that this one I added directly to the context. I didn't have to add it to the products table. That's because Entity Framework knows that this is a product object, a product entity, and it knows that it belongs in the products table. Finally, we're going to call save changes on the context. Let's run it and see what happens. As expected, 2 products have been added to the products table, our squeaky dog bone and our tennis ball 3-pack. Well, now that we've added information, we've created some entities, let's try reading information from the database. Using that same Contoso Pets database context, I'm going to query the products table using a Fluent API. Fluent APIs use extension methods that chain methods together and lambda expressions to specify the query. In this case, we're looking for any product where the price is greater than 5, and we're going to order by name. Then we're just going to write it all out to the console. If you don't like the Fluent API syntax, you can also use the LINQ syntax. LINQ syntax is very similar to SQL code. Let's replace the Fluent API syntax with the LINQ syntax. Both of these methods are equivalent and result in the same queries to the database. As expected, our one product whose price is greater than 5 shows up in the results. Now that we've read data from the database, let's try editing a record. To edit a record, first we have to get a reference to it. We'll query the table, looking for any product whose name is squeaky dog bone, and take the first or default. In the case that there's no record that matches that name, we'll get a null. So we'll check to see if the squeaky bone object is a product and not null, and if it is, we'll set the price to $7.99. Finally, we'll save our changes. Since we changed the price to greater than 5, squeaky dog bone shows up in the result set now. The final thing we're going to show is how to delete a record from the database. To delete, you simply pass a reference to the entity to the remove function on the database context. That's how easy it is to use Entity Framework Core to store your .NET objects in a database. In the next video, we're going to show how to use an existing database. In the meantime, if you'd like to try an interactive tutorial for Entity Framework Core, go to aka.ms/learn-ef-core.